Hello, my name is Dr. Ken Gallardi. Thanks for watching my other videos on the complete photon model, a complete model that facilitates understanding of both the particle and wave nature of radiation. I posted videos showing the model itself and several applications of that model, including my most recent video on what energy is. That's perhaps the most fundamental issue in physics. Now I want to look at how this model explains fundamental forces. And I'll look at gravity, the electrostatic interaction, magnetic and nuclear interactions. And you will see that the 1 over r squared variation for the long-range forces is easily developed from this treatment. There are three fundamental issues in understanding interactions. They are, first, how does an object transfer energy from itself to a second object some distance away? Second, how does the receiver know what to do with that energy? And third, where does the energy originate from? Typically, we ignore these questions and simply assert that the force dictates how the second body will respond. Of course, there are general relativity answers associated with curvature of space-time and quantum theories as well, but I present a simplified model that follows the energy. If a body changes its motion, then this model asserts that energy has to be involved and energy has to be conserved. And I suggest that this energy is transmitted via a photon. Some will call it a graviton in the case of gravity, but I choose to generalize to all the forces and treat the energy as simply a photon. A photon carries with it sufficient details to direct the response of the receiver, and I suggest that it does this via a unique combination of frequency, or energy, and spin, which identifies the polarity, and the direction from which it came. I'll come back to these in a few minutes. The answer to the second is that the ways a receiver apportions the energy that it absorbs is in accordance with the options it has available, which for these examples includes translational motion of the body as a whole. The causal uncertainty associated with the photon interactions prevents us from getting a detailed description of the absorption process and limits us to describing the result of the absorption and then examine how the photon structure facilitates that response. In the case of the four forces being examined, the details that the photon brings with it, energy, spin, and direction, enable the outcomes as we will see. The source of the energy is the mass of the object, and it is the result of a transformation of a very small portion of the body into energy as per Einstein's transformation equation is shown. You see this by looking at it one elementary particle at a time, and then looking at the total energy of that body as shown. These interactions must work for the particle at rest, in which case the total energy resolves back into Einstein's transformation equation. I conclude that some of the mass must be transformed into energy, which in turn leaves as a photon. So it is a suggestion of this presentation that all mass particles are inherently unstable, but they decay very slowly. When they do decay, the small amount of mass lost is transformed into energy and leaves as a photon. So first I will develop this for gravity, perhaps the simplest of the four. First, we note that while a mass particle has a spin, giving it a directional feature, these spins are not aligned within a given mass, so that the effect is as if the masses did not possess a preferred direction. The result is that while a photon leaving an elementary particle may have a preferred direction with respect to the spin, the randomness of the spin implies that the photons leave in a random direction. Putting a large number of these masses together implies that the photons leave in a spherically symmetric pattern, and the number n of photons emitted in a given time will be proportional to the total mass. The absorbing body can be represented by an absorption cross-section A, the size of which is proportional to the mass of the receiving body. The number of photons absorbed by the receiving body is proportional to both the size of the absorption cross-section, which determines how many photons strike it, and to the probability of a given photon being absorbed by that cross-section. Not all photons that strike the cross-section are absorbed because a body behind this one will also feel the gravitational effect. The spherical symmetry of the distribution of these photons enables one to calculate the fraction of the emitted photons N that strike this cross-sectional absorption area A in a given time. And the answer is the ratio of A to the total area of the sphere, 4 pi r squared, where r is the distance between the two bodies. This spherical symmetry is the reason that these long-range forces decrease as the square of the distance. Putting these together for the gravitational relation yields the energy of the number of photons absorbed in a given time as shown, where m1 is proportional to the number of photons emitted, m2 over r squared is proportional to the fraction of these photons that are actually absorbed. This expression is the familiar gravitational formula, but now thought of in terms of energy. The feature of the photon that's used to determine the response is the direction from which the photon came, and the mass responds by moving in the direction from which the photon arrived. It is noted that the spin of these photons is not significant, either because they arrive randomly or because the absorption cross-section at that frequency is insensitive to spin. It's suggested that the electrical interaction is similar to the gravitational one, but with two significant differences. First, the frequency of these photons will be different than that of the gravitational photons. And second, these photons need to carry the charged nature of the emitting body, and it is suggested that this is differentiated by the spin of the photon. As with the gravitational interaction, the photons will be emitted with a spherical symmetry, and the number of them in a given time, n, will be proportional to the total charge q1 of the emitting body. The fraction striking the electrical absorption cross A. As with the gravitational interaction, the photons will be emitted with a spherical symmetry, and the number of them, n, emitted in a given time will be proportional to the total charge q1 of the emitting body. The fraction striking the electrical cross-section A will be equal to A divided by the area of the sphere of the radius r, namely 4 pi r squared, which introduces the 1 over r squared dependence. The absorption cross-section A will be proportional to charge q2 of the absorbing body. Putting these together yields the familiar expression for the electrical interaction, but this time in terms of energy. Both the direction from which the photon arrived and the spin are used to determine the response of charge q2. This argument demonstrates that both the gravitational and electrostatic force will decrease precisely as the square of the distance, and that this is simply a geometry issue. Furthermore, it shows that the response of the body as a whole is incremental rather than continuous because of quantization. For the magnetic interaction, the source can be thought of as a charge moving in a specific direction, resulting in a distribution of the emitted photons not being spherically symmetric. In fact, the law of Biot-Savart suggests that the emitted distribution of these photons varies as the sine of the angle between the direction of the current element and the direction toward the point in question. It is suggested that these photons emitted by this moving charge will carry this information by 1. The spin, which carries the information on the polarity of the current element, and 2. By the photon distribution, which carries information about the orientation of the current, and 3. By the direction from which the photons arrive, which is used to define the direction of the response. The absorption will follow the identical pattern as above, and the resulting motion that ensues will take into account both the details of the photon brings that describe the initial magnetic influence and the charge and motion of q2, the receiving body. The nuclear force is similar to the gravitational case, except that this nuclear interaction is a short-range interaction. In this model, the photons will be emitted in a similar manner, but the short range is facilitated by these photons having a very short half-life. While nothing is permanently stable, experimentally other photons appear to have a very, very long half-life, so that in practical terms they are stable. But the nuclear interaction photons must have a very short half-life. These photons have two possible ends. 1 if they are absorbed, and 2 if they decay. In the case where these nuclear energy photons are absorbed, the analysis of how the absorbing media uses the energy is analogous to the gravitational interaction. But if the photons decays, which means that it is not absorbed as a photon, then it decays back into matter. It both originated from matter, which was transformed into energy, and ends as energy being transformed back into mass. This is Einstein's transformational equation, as shown. So let me summarize how this complete photon model treats interactions that span distances. First, the energy transfer associated with the gravitational, electric, magnetic, and nuclear interactions are done via the emission and absorption of a photon, which results in a stepwise response due to the quantization of the photon. Second, the important details of the emitting body are contained in its spin, the distribution of the photons, and the direction from which the photons arrived. Third, the gravitational electrostatic interaction vary as 1 over r squared, and this arises because of the spherical symmetry of the photon emitter. Fourth, there is no need to invoke the concept of an independent force, even if it is a convenient way to describe the interaction. And fifth, the electric and magnetic fields are not necessary to understand these interactions. Putting these together, the result is that gravitational, electric, magnetic, and nuclear forces do not exist. Instead, one has a stream of photons which carry energy and the properties from one mass to another, which together with the properties of the receiving body dictates the motion of the receiving medium as a whole. Well, that's the complete photon model's answer to the fundamental question of what forces are. Thanks for watching. Please subscribe and add a comment. And please pass it on to others, particularly those in the physics community. Thanks again, and God bless.